All right, so we're in chapter 3, section 1, and you can read linear inequalities. And you're going to feel like this could be kind of a review from some prior class that you might have taken, and that's okay. If not, then still all right. We're going to pretend like we know nothing here. So we're going to go ahead and get started. So definitions of the inequality signs, and you can read this, you can pause this however you feel like, but if A is less than B, that means A lies to the left of B on the number line. If A is less or equal to B, it means exactly what we said prior, but also can be equal to B, right? And then now if we go to the bottom half of what we have here, we have A is greater than B, means that A lies to the right of B on the number line. If it says A is greater than or equal to B, that means it could be greater than or equal to, okay? So we're going to move on here and inequality signs. So which of the following statements are true? So I want you to go ahead and take a moment, pause, and tell me which are true, which are not true. So go ahead and pause now, and then when we come back, you'll have all the answers. All right, so hopefully you taken the time to pause it real quick and try to look at the number line here. So 1 is less than 4, -1 is greater than -4, and so forth, and they just so happen to all be true. Okay, now the very last one, 3 is greater than or equal to 3. Remember, 3 isn't bigger than 3, but it's equal to. That's what that or means, that the line underneath the greater than. So we have a couple of properties for inequalities, and these might be pretty basic properties that you might think of. But the first property says if A is less than B and C is any number, that means we can add C to either side and it's still true. This can be the same for any inequality that we put in there, less than, greater than, less than or equal to, or greater than or equal to. Okay, so basically it says that, again, if we have a number less than a number, so A less than B, if we add just C, which is any number, to both sides, it still holds true for the inequality. Also, I should say too, and it says here too, is it can be subtracted as well, added or subtracted. Okay, so let's just see this inequality property in place. So first is solve the inequality x plus 5 is less than or equal to 5. Or sorry, less than or equal to 2. The first thing we want to do here is we want to isolate x. So we're going to go ahead and move that 5 over by subtracting it from both sides to isolate the x. So here again, we have x plus 5 less than or equal to 2. We're going to subtract the 5 to both sides because we want to get that x by itself on the left side. And that gives us x is less than or equal to -3. Okay, and so again, it says the values of x for which the inequality holds are exactly those x less than or equal to -3. That's using the first property. Second property says that if A is less than B and C is positive, then if I multiply both sides by that value, the inequality stays the exact same. And this says multiply, but we can also say divide. We divide is the same thing as multiply because we can say, if we say divide by 2, we can say multiply by 1/2. That's equivalent. Now, the second part of the property says if A is less than B and C is negative, then what happens is the inequality flips, and that's because we're basically flipping the number lines how it looks. So we're going to say AC now will be greater than BC. And again, this holds no matter what the inequality, less than, greater than, less than or equal to, or greater than or equal to. So let's go ahead and go through our second property here, and we can see it in play here. So solve the inequality, -3x plus 1 is greater than 7. First thing we want to do is we want to subtract 1 from both sides to isolate the x. So here we have -3x plus 1 greater than 7. Subtract the 1 from both sides, and then we end up with -3x greater than 6. So that's using the first property, the inequality property number 1. Now, next we still need to isolate the x, so we're going to go ahead and divide both sides by -3. Or again, we can say we multiply by -1/3 to isolate the x. And when we do this, we get x is less than -2. Again, we flip the inequality only because we're multiplying or dividing by a negative value. If that 3 was not negative, we just had 3x greater than 6, and we divide or multiply by that 3 or 1/3, then it would be positive, and that inequality would still stay as greater than. So next is the slope-intercept form of a linear inequality. The linear inequality of the form cx plus dy is less than or equal to e can be written in the slope-intercept form. So first, and we went over this in a prior lesson. With slope-intercept form is mx plus b. So it usually was y equals to mx plus b. Now we're gonna have inequalities, and this is the best way for us to really start to graph these. So these are the two types of way we want to graph them. It's much easier. So we have y is less than or equal to mx plus b, or y is greater than or equal to mx plus b. Or we can say x is less than or equal to a, or we can say x is greater than or equal to a as well. All right, so I'm going to let you try this. I want you to basically use the properties that we've already done and used, and I want you to solve for 5x minus 3y less than 6. But remember, I want you to solve for y. And then when we have 4x greater than or equal to negative 8, I want you to solve for x. So I'm going to go ahead and stop this for just a brief second. And then I want you guys to go ahead and solve these separately, of course. And then when you come back, you'll have the answers here. So I'm just going to pause for a second. So hopefully you've taken the time to pause and try to solve these separately. So I'm going to show you here what we have. So when we have 5x minus 3y less than or equal to 6, what we're going to do is we're going to, again, we're solving and trying to isolate that y. So we're going to subtract 5x from both sides. When we get that, we have negative 3y less than negative 5x plus 6. And the last thing is that we're going to either divide everything by negative 3, or we can also say we're going to multiply everything by negative 1/3. When we do that, remember, we have to flip the inequality because we are multiplying or dividing by a negative value. And then we have the simplification on the right side. So we have that kind of setup of y greater than mx plus b, where m is our 5/3, that's our slope, and then b is our y-intercept, and that is negative 2. Now in b, we get to b, we see 4x greater than or equal to negative 8. All we need to do is divide by 4, and we keep the inequality greater than or equal to because we are not dividing or multiplying by a negative value, only a positive 4, or you can say multiplying by a positive 1/4, however you look at it. So next we want to know, how do we graph something where it says x is greater than or equal to a, or x is less than or equal to a, or we can also say, yeah, I'll just leave it at that. So here we go. So the graph of inequality. We said x is greater than or equal to a consists of all points to the right hand, so the right of, and on the vertical line, x equals a, and I'll show you a visual here shortly. If it says x is less than or equal to a, consists of all the points to the left of, and on the vertical line, x equal to a. All right, how we're going to graph this might be different than what you have seen in the past. I'm going to stay consistent with the text here. The text says this last bullet will display the graph by crossing out the portion of the plane not a part of the solution. You might be used to the opposite. That might be taught in different sections and courses that way. However, this text keeps it as crossing off the portion you do not want to use. So I'm going to keep it consistent. So then when you look back at the textbook, it all kind of makes sense when you're looking back at the notes. So here's our fourth example here. So graph the solution to 4x greater than or equal to negative 12. And if you remember, okay, we first write in standard form. So we're going to divide both sides by 4. And we get x is greater than or equal to negative 3. So now when we do that, what we're looking at is we're really trying to graph that line, x equals negative 3. That is a vertical line. And then it says we want everything where it says x is greater than or equal to negative 3. If we go back to our previous slides, it's our first bullet point. It says we want everything to the right of and on the vertical line, x equals that number. So this is what the graph should look like. And you can see that we have this graph, and it says x equals negative 3. That's our vertical line. And we want everything to the right of it, which means that we're going to cross everything to the left of it out. So next we're going to talk about looking at more of a different kind of inequality. It's the same thing as what we just previously did, except for now we don't just have a value. We're going to come up with a line that's diagonal. And we're still going to cross out the portion that does not satisfy the inequality. So look at that second number here, and it's actually the second sentence and the third sentence. So the graph of y is greater than or equal to mx plus b consists of all points above or on the line, and the graph of y is less than or equal to mx plus b consists of all points below or on the line. All right, so those are your two guiding kind of not, I don't want to say questions, but your guiding statements that you're going to follow. So here's our example 5. Graph the inequality 4x minus 2y is greater than or equal to 12. And we want to first write in standard form or slope-intercept form, and we want to solve the inequality for y. So first thing we want to do is we want to move that 4x over. So we're going to subtract 4x on both sides. Negative 2y greater than or equal to negative 4x plus 12 is what we get. Now we want to isolate that y still, so we want to divide everything by negative 2, or we can multiply everything by negative 1/2. Again, same exact thing. When we do that, we have to remember we want to flip the inequality because we did divide and or multiply by a negative value. And then our right side gives us 2x minus 6 when we simplify those fractions. So what we are graphing is, how you should look at it is you're really graphing the line y equals 2x minus 6. And then you have to talk about the shading. So remember, 2x minus 6, negative 6 is our y-intercept. So we're going to go on our y-axis and go down to negative 6, and you plot the point there. And then that 2 is our slope. And again, our slope is our change of our y over our change of our x, which is 2 over 1. So we will go up 2 and then to the right 1 because it's all positive. So this is roughly what the line looks like. And then because it says y is less than or equal to, then what we're going to do is we are going to shade everything above it. And that is exactly what I'm going to go back to the slide. Right here is our last sentence and that second restraint. It says the graph of y is less than or equal to mx plus b consists of all points below or on the line. Remember, we want to cross off everything that does not satisfy the inequality. And this is why we cross off everything above the line. Everything below the line are things that we can use that satisfy the inequality. And again, what this is saying is that when we have just a system where we have values, we have equal signs, everything on that line is a solution to our equation. When we have inequality, we have different things. We don't just have on the line that is a solution. We have everything that is not shaded in this case that is also a solution. So any of the points that are not shaded will satisfy this constraint that we can substitute into 4x minus 2y greater than or equal to 12. And that's important because when we start doing systems and we start using word problems, which is more of our, well, it's more of next section, to be honest, with word problems, you'll start seeing these. And then the following section will build upon this even more. So a graph of system of inequality. So we have a system now. So we're having more than just one inequality. And the first thing is we need to make it all look like standard form, meaning we have to know how to be able to graph it. So that very first inequality of 2x plus 3y is greater than or equal to 15. You need to solve the inequality for y. So it should say y on the left side, and then it might be greater than or equal to, or you might have to flip it, less than or equal to. And then you have values on the right side. The second inequality of 4x minus 2y is greater than or equal to 12. You need to solve that one for y as well. And the very last one is already solved for you in our standard form because it says y is greater than or equal to 0. So before I give you what standard form looks like, I want you to pause for a minute here and manipulate those inequalities to solve for y. So I'm going to go ahead and ask you to pause now and then come back here when you're done. All right, so here is what you should get when you solve for y for those first two inequalities. You should get y is greater than or equal to negative 2/3 x plus 5. And then for the second inequality, you should get y is less than or equal to 2x minus 6. Now, the first inequality, you did not have to flip the inequality because you divided by a positive 3. But that second inequality, you had to divide by a negative 2. And so that's why that greater than or equal to becomes a less than or equal to. Now, when you do graph this, the next graph that I show you does have all three graphs on one, so don't feel overwhelmed. And you're going to see it's color-coded, so I'm going to go ahead and explain to you which colors are the graphs. So our first inequality, y is greater than or equal to negative 2/3 x plus 5, is shaded in blue. You can see we have 5 is the y-intercept, and negative 2/3 is the slope, so we're going to go down 2 and to the right 3, and then we can keep doing that with our slope. We can get our straight line there. Our linear equation goes to a line. And then we shade everything below because it says we want everything above it, right? It says greater than or equal to. The green line is y is less than or equal to 2x minus 6. So we go down to the y intercept, which is the point -6. So the point is 0, -6. We plot there -6 on the y-axis. And then we're going to use the slope of 2. So it's up 2 and then to the right 1. You continue that slope to create that straight line. And it says that we want everything is less than or equal to, so we have to cross off everything that is above the line. So that's why the green line is shaded above. And then the last thing we have is y is greater than or equal to 0. And you have to think, this says, where are our y values bigger than or equal to 0? Just think about your y-axis. First off, 0 is at the origin, so you know that's where the line is going to be. But it's the whole x-axis is your line, right? Because that is the dividing thing of where all your y values become positive and negative. Well, we want y values to be positive is basically what it's saying because it's greater than or equal to 0. And our y values are all positive above the x-axis. So that is why we're shading everything below. So you can see, let me see if I can get my laser pointer here, if this will work here. This is the region that will satisfy all of our constraints. And if we continue this line, it would continue. But all right in here, this is the region that is not crossed out. So all of these point values here are values that will satisfy all 3 of these constraints. So summary. Okay, summary is, and you can read this. I'm not going to go too into depth with this, but you can see that the first one we talked about the properties of inequalities, and we're going to basically flip or switch or reverse the inequality sign if it's multiplied by a negative number or divided by a negative number. We talk about how we graph the inequalities. And last part, I didn't say this next bullet point. I didn't quite say the term. I should have. But if we're going back to this here, that white surface over here, this right here is what we call our feasible region or our feasible set. And that's what our very last bullet says. The feasible set is something that satisfies all the inequalities, all the constraints that we've given.